here the question comes. A bomb of 12 kilogram explodes into two parts. One is having a 4 kilogram mass, that is 4 kilogram mass, and the one is having 8 kilogram mass. So they exploded from the initial position, and it was two pieces were at rest, exploded, would get the velocity of 8 kilogram is given as 6 meters per second, and the velocity of the 4 kilogram mass is to be found because they ask what is the kinetic energy of the other one. So they have to find what is the kinetic energy of this. So what law of conservation of linear momentum says is, for any collision, it could be explosion also, the total linear momentum before the collision is exactly equal to the total linear momentum after the collision. So before the explosion, two pieces were at rest. So the total momentum before the collision is exactly equal to 0, which is equal to total momentum after the explosion, that is just mass m1 v1 plus m2 v2. That implies 0 is equal to mass m1 is just 4, v1 is unknown, but that's what I want though, to find out the kinetic energy of the mass 4 kilogram plus m2 is known, that is a 6. I'm sorry, it's 8 kilogram times v2 is given. So good news here. That implies v1 is equal to minus 48 by 4. That implies minus 12 meter per second. That's what I got to the speed of the 4 kilogram mass. But what they ask is the kinetic energy of that one. So kinetic energy of the 4 kilogram is half m1 v1 square. That is half. Mass is 4 kilogram. Velocity is found at minus 12 whole square. So it is just 144 into 4 by 2, which will give you the value 288 joules. So option is B. Going to the next slide. A body of mass 5 kilogram thrown vertically up with a kinetic energy is 490 joule. Right? Initially it has a kinetic energy 490 joule when it is thrown vertically up. The height at which the kinetic energy of the body becomes half of its original value. So you need to find out at which height the kinetic energy, whatever it has, becomes the half of its original one. That's the original value is given, that is a 490 joule. That's what you need to find out right now. G is given as 9.8. Now here is your ball vertically thrown up. Initial kinetic energy is given, that is a 490 joule. At certain position with the height h from the point of projection, at this position the kinetic energy becomes half of the original one, that is a 490 joule. Right? That's what it happens. So that is dash joules. Now you need to find out the height, right? You got to know what is the kinetic energy at this point, right? But the thing is, you need to find out the height. So what law of conservation of energy says is, mechanical energy says is, the sum of kinetic energy and potential energy becomes constant if the force involved in the system is conservative. But these guys, see, when the body vertically thrown up, kinetic energy keeps increasing, right? Decreasing. At the same time, height keeps increasing. That means the potential energy keeps increasing. So that means, so when it goes up, when it reaches this point, there will be some loss of kinetic energy. That is 490 by 2, that amount, which is appearing in terms of potential energy. That is just potential energy. That's a gain in potential energy. So loss of kinetic energy is that 490 by 2 is equal to gain in potential energy, that is nothing but the gravitational potential energy, that is equal to mgh. I need to find out what is a height, right? So h is equal to 490 by 2 times mass times g. That implies 490 by 2 times mass is given, right? So very good news here. 5 into 9.8 is our value. So you would get, so if you just calculate, you'll get 5 meters. So answer is the first one. We've got a question here. You've got two bodies, A and B, and they have got equal linear momentum. So PA is equal to PB. That's what they have given. So both of them have equal linear momentum. So that's what I've got is PA is equal to PB. The kinetic energy of A is, so that EA is, so greater than, lesser than, equal, or 0. So I've got options. I got to have an equation which is relating the kinetic energy and the momentum. That is a P squared by 2m. Remember, P is same for both the bodies, A and B. Energy is inversely proportional to mass, right? So now, the thing is, lighter body I, that means young A, mass of A is lesser than mass of B, because they're told that A is lighter than B. That is, mass of A is lesser than mass of B. That means E1 by E2, I'm sorry, EA by EB, because I've got two bodies, A and B, is equal to, see, this energy is inversely proportional to mass, so this is young B by young A, because they are inversely proportional. So I can write EA by EB is equal to, since mass of B is greater than mass of A, so for all the values of mass of A and B, this ratio will be greater than 0, greater than 1, because this is more than this. So it should be greater than 1 for all the values of masses of A and B. That implies EA is greater than EB. That is a kinetic energy of the body A, that's what they want, is greater than the kinetic energy of the body B. So this is purely by law of, it is purely by equation is equal to P squared by 2m. Since P is constant for both the bodies, energy is inversely proportional to the mass. That's what you have got. Here is a graph, F versus X graph. So what is asked is the work done from 1 to 5. That's what they asked. So along y-axis, force is taken. Along x-axis, displacement is taken. You need to find out the work done. It's very understood that if you plot work, if you plot force versus displacement, if you take down the area under the graph, Fx, you would get a work done. If you want to find out the work done, if you're given with the force displacement graph, you need to find out what is the area under the curve. So that's what they have given. So this is a force in terms of Newton. This is displacement along the x-axis. So you need to find out the area under the force displacement curve to find out the work done. But what they have asked is the work done from x is equal to 1 to 5. So I need to find out the total work done in this portion. Now, work done is equal to area from x is equal to 1 to x is equal to 5. From here to here I need to find out area. So area of this rectangle, this rectangle, this rectangle plus this triangle. That is, area of this rectangle is just length into breadth. Length is going to be 10 times. Breadth is 2 minus 1 is 1 plus. Here, this is just a 5 into. This is 3 minus 2 is just 1 plus. Here, this is a negative direction. Force is negative. So I need to write 4 minus 3 is just 1 into. This is minus 5 plus. This one is just a triangle. This is area is half into. Length is just 5 minus 4 is just 1 times. This is height, which is equal to 10. That is equal to 10 plus 5 minus 5 plus 10 by 2 is a 5. And you lose your 5, it is 15 joules. It's a unit of work. So if you take the area under your graph, you would end up with finding out the work done. This question had been appeared for AIEEE 2003. The spring of force constant 800 Newton. per meter. That's a spring constant for the particular spring given. The work done in extending it from 5 centimeter to 50 centimeter is. By the work energy theorem, the work done by the force is exactly equal to the change in energies. Since it's a case of spring, the work done by the spring force or restoring force is just change in potential energy minus half kx1 square. So half kx square is a potential energy. So final potential energy minus initial potential energy will give you the work done by the restoring force, which is equal to half k is given, that is 800 tons. x2 square is 15 centimeter, that is 0.15 whole square minus x1 square is 5 centimeter, 0.05 whole square. So if you just calculate, this work done will be 8 joules. Go to the next question. You've got two particles, masses m1 and m2. They have the same kinetic energy. Last time it was a case of same momentum. This time they have the same kinetic energy. The momentum are in the ratio. This time energy is equal to P squared by 2m. E1 is equal to Et, that's what they have given. That means P squared is directly proportional to 2m. P is directly proportional to root 2m. That's how the momentum and mass relate by keeping energy constant for both bodies. But what is asked is the ratio of their momentum. So P1 by P2 is directly proportional to square root of 2m1 by square root of 2m2. Since momentum is directly proportional to m, I've got same suffix everywhere. So that is equal to root to cancel, square root of m1 by m2. So they are in the ratio square root of m1 is to square root of m2. So going to the option C. That's what the answer is. Next, coming to the two particles again. A stationary particle explodes into two particles of different masses, m1 and m2. But what happens is they move opposite direction after the explosion with a velocity v1 and v2, individual velocities of two different particles after the explosion. The ratio of their kinetic energy is AIEEE 2030. So I've got two masses, m1 and m2. They collide and they explode and they move in two different directions. So while law of conservation of angular, linear momentum says the total momentum before the explosion is equal to 0 time is equal to total momentum after the explosion, but they have given that both move in two different directions, opposite directions. So minus sign I will say instead of plus times m2 v2. This implies m1 v1 is equal to m2 v2. That I'll write as v2 by v1 is equal to m1 by m2. But they have asked what is the ratio of their kinetic energy. So kinetic energy E1 by E2 is equal to half m1 v1 square by half m2 v2 square, which is equal to half of cancel, so m1 by m2, so v1 by v2 whole square. That is equal to m1 by m2. So v1 by v2 is just, so I can write from here, v1 by v2 is equal to m2 by m1. So I'll substitute m2 by m1 whole square. So m1 square left here, m2 square by m2 is just m2. So I left with m2 by m1. So I can find out the option A is the ratio of the kinetic energy. Going to the next question. So thanks for watching. I will just continue after some time.